Hi, welcome to Varenya's Photon Online Educational Academy for IIT and NEET examinations. This is Guntuka Srinivas. This channel mainly focuses on the basic concepts associated with the physics, chemistry, and mathematics subjects related to IIT and NEET examinations. In the previous session, we have seen about the acceleration. Let us see the graphs related to acceleration and some numericals based on this concept. In the previous session, we have seen graphs the first graph was if we draw displacement time graph, ST graph, if we draw displacement time graph, the slope of the above graph, slope of the above graph gives velocity, gives the velocity. For the clarity, we have drawn the ST graph, displacement versus time graph. And if we draw that graph, the slope of the displacement versus time graph gives us velocity, gives the velocity. Similarly, if we draw velocity Vt, velocity time graph, then the slope of graph gives us acceleration, We have run the velocity time graph. If we draw the velocity time graph, the slope of that graph gives the acceleration. Is it clear? Now, let me show two graphs here. Example 1, if I take. This is x-axis, this is y-axis, horizon. On the x-axis, time, t, we have taken. On the y-axis, we have taken velocity, v, on the y-axis. Suppose, let us say that if the graph is like this, observe carefully. On the x-axis, we have taken time. On the y-axis, we have taken velocity. This is velocity time graph. If the velocity time graph appears like both, what does it indicate? Just now we have seen that the slope of the Vt graph gives acceleration. That means the slope of this curve gives the acceleration. Let me draw the slope line. Observe. Let me draw the slope line. Suppose if I draw a line here, a tangent here, this is the slope. Okay. If I draw a line here, this is the slope. That means, observe here, observe carefully. This is theta1, this is theta2. As the curve is like this, theta1, the slope is theta1, and whereas the other line indicates theta2, the slope. That means slowly the slope is increasing. Theta1 is less. Theta1, here I write theta1 is less than the theta2. So slowly the slope is increasing for the curve. If I draw a line here, observe a line here. Again, the slope of this is very less than the slope of this, than the slope of this. That means slowly as the curve is moving, with the increase of the time, slope is slowly increasing. Clear? As the slope increases, what the slope indicates? The slope of VT graph is known as acceleration. That means as the slope is increasing, acceleration is increasing. Here I clearly write slope of VT graph is acceleration. Slope of VT graph is acceleration. Yes? Slope of VT graph is acceleration. Okay. As slope is increasing, the acceleration also increases. Be clear with the above concept. Slowly, as time is increasing, slope is also increasing. When slope is increasing, slope of velocity time graph is nothing but acceleration. So as slope is increasing, the acceleration also increases. That means above type of graph indicates increase in acceleration. Just the increase in just mere observation of slope indicates how the acceleration is changing. Is it clear? Okay. Now, let me take up another graph. That is example 2. I take up. This is the graph, x-axis, y-axis, horizon. On the x-axis, velocity v1. On the y-axis, time t. So, graph is a straight line. Passing through the horizon. Observe, graph is a straight line passing through the horizon. This is V, and this is T. By VT graph, it is a velocity time graph. VT. Clear? It is a VT Now, slope of VT graph is acceleration. Here I highlight. Slope of VT graph is acceleration. Slope of VT graph is acceleration. Yeah. Now, observe the slope. Suppose if I draw a line parallel to x-axis, this line is making theta. If I draw a line here parallel to x-axis, the curve, the straight line is making theta here. If I draw a line parallel to x-axis, this line is making theta here. That means theta is constant. Theta is constant. When theta is constant, slope is constant. When slope is constant, the slope of VT graph is nothing but acceleration. So acceleration is also constant. That means it indicates that as per the above curve, slope is constant. Slope is constant. Hence acceleration is also constant. Be careful about this point. Okay, as slope is constant, acceleration is also constant. So earlier we have seen one graph. Now we have seen another graph. Both are velocity time graphs. Thus, again I am repeating, the slope of velocity time graph is nothing but acceleration. As theta changes, acceleration changes. When theta is constant, acceleration is also constant. Clear? Now, let us solve some numericals. Let me take up first problem. Here, velocity is given by an expression. Velocity is given by an expression. V is equal to 2t square minus 4t. V is equal to 2t square minus 4t. Find acceleration. Find acceleration at t is equal to 3 seconds. Find acceleration at t is equal to 3 seconds. Observe the problem carefully. This is velocity expression. This is the velocity expression mathematically given. V in terms of t is given. Now E is asking us to find out acceleration where t is equal to 3 seconds. That means, observe carefully the problem. Acceleration is asked at a particular instant of time. T is equal to 3 seconds. Means time period, the rate of change is very, very small. Time is very, very small at that particular instant. Means instantaneous acceleration is asked. Instantaneous acceleration is asked. What is instantaneous acceleration? Instantaneous acceleration is dv bar by dt. Mathematical expression is dv bar by dv. Instantaneous acceleration. At a particular instant, t is equal to 3 seconds. It is asked. This is the mathematical expression for that. Clear? differentiation of velocity if you do with respect to time, that gives the acceleration. Now, observe carefully. V expression is given as 2t square minus 4t. So, dv by dt, differentiation, 2 into 2 is a constant into t square differentiation is 2 into t minus 4 is a constant. T differentiation is 1. So it becomes 4t minus 4. 4t minus 4. This is nothing but acceleration A bar. Acceleration A bar. Okay? Now, acceleration is asked at acceleration at t is equal to 3 seconds. Yes, substitute in this expression t is equal to 3. Then it becomes a bar at t is equal to 3 seconds becomes 4 into 3. T is equal to here is 3 seconds minus 4. So 12 minus 4, 8 meter per second square. Meter per second square. This is the answer. Clear? SI units, meter per second square. Okay, this is the solution of the